So question 2 from graphing of a function. So it says answer the questions about the following functions. So we have f of x equals x plus 8 divided by x minus 7. So we have what's called a rational function since there's a numerator and denominator. So the first thing they ask us is the point 4, -3/2 on the graph. So we're going to have some we're going to have some yes or no answers here. So for 4 -13/2 to exist, remember the 4 is the x value, and then this is going to be the output value. So if I look at it from a function concept, the 4 is going to go into the function. The function is going to have some number plus 8 divided by some number minus 7. And then out comes our output value, or our y value. So the value that we're putting in is a 4. Bless me. So 4 plus 8 would be 12. 4 minus 7 would be a -3. So again, if we do that on calculator, 4 take away 7, that does give us a -3. 12 divided by -3 is actually going to be a -4. So if we do 12 divided by -3, it does give me -4. So is the point 4 -13/2 on the calculator? Well, remember, the input and output represents the ordered pair. So 4 -4 would be the ordered pair. So if 4 goes in, the y value that should come out should be a -4, not this -13/2. So the answer should be a no. So the first one says no because substituting x plus 4 in the equation does not result in this. So that looks pretty good. I like this one. The other no is they're saying substitute -13/2 in. We're substituting the 4 in. So this one says you're substituting this -13/2 in. That's not correct. So our best choice is this answer here. So part B says if x equals 1, then what is f of x? So again, the way we're doing this is your function is this x plus 8 over x minus 7. So again, our function is f of x equals this x plus 8 over x minus 7. So what they want us to do is actually figure out what is f of 1. So if I put 1 into the function, we're going to have 1 plus 8 on the top, and we're going to have 1 minus 7 on the bottom. Well, 1 plus 8 on the top would be 9. 1 minus 7 would be -6. It looks like there's a common divisor of 3. So if I divide the numerator by 3, I should also divide the denominator by 3 to keep it equivalent. So 3 does go to 9 3 times. 3 does go into -6, -2 times. So again, if you want to double check that, you can type in 9 divided by -6 into the calculator. It'll put it as a decimal. And then if we want to make that to be a fraction, we can hit the math button. And then the first one says convert back to a fraction. If I hit enter, it says answer. That arrow kind of means convert to fraction. Hit enter, it gives me -3/2. So that would be the answer there, would be -3/2. So using this information, list the points on the graph of f where x equals 1. So the ordered pair is going to actually be 1 -3/2. So remember, a function, we have an equation, and when what you're doing is essentially generating a table, you have this xy table where 1 goes in and -3/2 came out. And notice how that represents an ordered pair as well that can be graphed. So looking at C, it says if f of x equals 2, then what is x? So remember, f of x equals 2, that means the output value, or in other words, y is equal to 2. So when I work out my problem here, let me put this 1, -3/2 here as an ordered pair. So remember, when you write an ordered pair, you have to use parentheses and all that. So sorry, now back to C. So notice how, again, y is equal to 2. We're solving for x. So again, our function is really going to be this, this x plus 8 over this x plus 7, because we don't know what x is, but we do know the output value is actually going to be this 2. Now, since this is a fraction over here, or a ratio, I can make this side over here a ratio too. So if we have a ratio equal to a ratio, what has to hold true is the cross products have to be equal. So when you cross multiply, I have to get the same thing. So if I go ahead and cross multiply, we can create a linear equation out of this. So 1 times x plus 8 is just going to be x plus 8. And when you multiply the 2 through, that's going to give you 2x plus this 14. So 2 times x is 2x, and 2 times 7 is 14. So again, to solve this equation, since x is on different sides of the equation, I have to pick on the little guy, which I'm going to pick on this x here. So I'm going to lose an x on each side. So it's going to give me an 8 over here, and this is going to give me an x plus this 14. So essentially what we have is this x plus 14 has to equal this 8. So again, if I finish this off, I can get x by itself by losing 14 on both sides. That's the property of equality. And we end up with x equals, and then 8 minus 14 is the math, and that would be a -6. If I want to double check myself, I could put 8 minus 14 into the calculator. That does give me -6. So using the information in the previous step, list the ordered pairs where fx equals 2. So remember, the x value is going to be the -6. The y value is actually the 2. So again, the x value was the input value, which this time we didn't know. What they gave us was the result, and we had to work backwards, solving the equation to find the input value. So -6, 2 would be the ordered pair. So next question says, what is the domain of the function? So remember, the domain of a function always starts out as a set of real numbers. And there's two things we have to watch out for: is we cannot divide by 0, and we cannot have a negative inside of a radical. So what's inside the radical has to be greater than or equal to 0. So notice how we do have a denominator. So there is a domain restriction if something can make that denominator equal to 0. So if you're unsure what makes x minus 7 equal to 0, you can just set x minus 7 equal to 0. And if we solve for x, we're going to get x equals 7. Well, because 7 minus 7 does create a 0 on the bottom. 7 plus 8 is 15, but 15 over 0 is going to create one of those things what we call undefined. There's not going to be a y value coming out. So remember, for every x value, when it goes to those calculations, there has to exist a y value. And when 7 goes in, the y value does not exist. So we have to exclude this. So again, it says use interval notation. So if I look at this with respect to the number line, what we're doing is we're excluding 7. So what happens is we have 2 intervals. We have this interval to the left of 7, and we have this interval to the right of 7. So if I'm using interval notation, we would say, if I'm looking at this left interval, the left bound is a negative infinity up to 7 in union with, and then the right interval, the 7 becomes the left bound, and we don't include it, so we use parentheses, and we go to positive infinity. So that would be our domain using interval notation. So E says list the x-intercepts, if any, of the function. So select the correct choice, and if necessary, fill in the answer box to complete your choice. Okay. So again, to find the x-intercepts, remember, if you're on the x-axis, if you will, there is an x value, but the y value has to be 0. So to find an x-intercept, when we have this function, we have to actually set this f of x set to 0. So our equation becomes x plus 8 over x minus 7. That has to equal then this 0. So again, if we cross multiply, notice how if we make this a proportion, we can cross multiply. But when you multiply 1 times x plus 8, that's still going to just be x plus 8. And then when you multiply 0 times anything, so 0 times x minus 7 is just going to turn into 0. And so therefore, x is going to equal -8. So -8 would be your x-intercept. If I was using technology, what I could maybe try to do is graph this. So if I type in f of x, clear this off. If I put in x plus 8 on the top, so I'm going to use the fraction button. Oops, wrong one. We'll have to quit that. So y equals, so alpha f1. So if I put x plus 8 on the top, and if we have x minus 7 on the bottom, if we graph that, we do see that the graph does cross the x-axis over here somewhere. Okay, so if I look at the table, second table, if we look at -8, notice that -8 does give me 0, so that would be the x-intercept. Okay, so it's a strange looking graph. We haven't really talked about those yet, but we do understand that an x-intercept is where a graph will cross the x-axis. And so again, looking at the graph itself, we can kind of see over here that there does exist some type of x-intercept. So 1, 2, 3, 4, 5, 6, 7. They're saying it actually crosses at that spot, but notice how it's really hard to see there. Now in your graphing mode, if you hit the zoom button, there is a box strategy, number 1. So if I choose number 1, what I can do is I can try to draw a box around where I think that that x-intercept is. So if I come over here a little bit, I like to open the top left corner. So if I go up in this area here, I can hit enter and it'll lock my box in and drop it on down and come in here and hit enter. And you can kind of see, if I use the trace button, if I come across with the trace button, you can kind of see that if you watch that y value, it's getting closer and closer to 0. And notice how around -8, we're seeing some really small values. But notice how, again, it's really hard to tell just from the graph because the graph doesn't actually take you spot on there to that. That you can kind of see, the graph does give you an estimation, but the actual answer has to be done algebraically or using the table. So looking at f, it says list the y-intercept, if any, of the function. So again, if we're talking about a y-intercept it's where it crosses the y-axis. So again, if you're on the y-axis, there is the x value is 0, and there is y movement. So to find a y-intercept, you're setting x equal to 0. So I'd have like 0 plus 8 over 0 minus 7. That's just going to equal what y is. So that's what f of x stands for, is the y. So if we do that math, it looks like we're going to get 8 over -7. So 8 over negative, so it's going to be -8/7. So if I quit this, if I type in -8 divided by 7, notice how it's just going to be some strange decimal, but we want to keep it probably as a fraction. So we'll just leave it as a, if I go back to math, change it back to a fraction, notice how it stays as -8/7. So the y-intercept looks like that's going to be -8/7. So again, if I look at the graph itself, if I go back to zoom and hit number 6, that'll reset the window. You can kind of see that the y-intercept is around -1. So it's right in that area. Notice how x is 0. You're getting around that area there is the estimation. Again, the only way to get this accurate is actually to do this algebraically. You have to do the math by hand at this point. So that concludes question 2.